All right, so today you guys are watching this video about trigonometric ratios. Now, trigonometry is derived from the ancient Greek language, and it means the measurement of triangles. Okay, and so that's what we're talking about. Now, you only use trigonometry when you're dealing with right triangles. Okay, and you use trigonometry when these are basically not special right triangles. So these aren't going to be 30, 60, 90 triangles or 45, 45, 90. Now, don't get me wrong, you can actually use these for those, but more than likely you want to use your special right triangles versus trig, okay? So a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Remember, ratio means fraction. So if you look at this triangle here, it says let triangle ABC be a right triangle. Sine, cosine, and tangent of the acute angle A are defined as follows. This is not sin. Okay, this is short for the word sine. Okay, so the sine of angle A is the side opposite of angle A divided by the hypotenuse. This here represents the ratio for the sine of angle A. Okay, if you look, side A is across its opposite of angle A, and we always know our hypotenuse is across from our right angle. So A over C will represent our ratio. This COS is not cos, it's cosine. Okay, so whenever you say it, you should say cosine of angle A is equal to the side adjacent to angle A over the hypotenuse. So adjacent, remember, adjacent means next to, okay? So the adjacent side is always the side that's next to the angle that you're given or that you're looking for, okay? Next to. It forms the angle that you were trying to take the cosine of, okay? So keep that in mind. So that would be side B over C, okay? So the adjacent side is B, the hypotenuse is C. The last one is not tan, but it's tangent. So the tangent of angle A is the side opposite of angle A over the adjacent, the side adjacent to angle A, which is A over B, okay? So these are your trig ratios here. These are your main ones, sine, cosine, and tangent. All right? Now, something that might help you in trying to remember this is something called SOHCAHTOA. And it's basically a way to help you remember your ratios. The S in SO represents sine. The O represents opposite. The H represents hypotenuse. And so if you remember, sine was opposite over hypotenuse. There is the part to help you remember that. Sine is opposite over hypotenuse. The C represents cosine. The A, what do you think? Adjacent. H, hypotenuse. So cosine is adjacent over hypotenuse. And the last one, T, what do you think it stands for? Tangent. O, opposite, A, adjacent. Tangent is opposite over adjacent, okay? So here they are one more time, just so you can see it, okay? SOHCAHTOA. So it's just something that helps you remember these. Now let's take a look at this example. It's asking us to find the ratio, sine A. Well, remember, sine is the SO part. Sine is opposite over hypotenuse. The side opposite of angle A is 8, and the hypotenuse is 17. So that will be our ratio. Now, if you're wondering, what if I can reduce my fraction? Should I? Yes, you should, okay? But 8 over 17 doesn't go in evenly, so we leave it as that. That would be the decimal 4.4706, okay? Just in case you were wondering. So that's just when you do 18 over 17. Let's look at cosine. Cosine, that's the CA, and so CAHTOA is adjacent over hypotenuse. Well, if 8 is my opposite side and 17 is my hypotenuse, that makes 15 my adjacent. It's adjacent to angle A. and then 17 is my hypotenuse. That doesn't reduce down, and then 0.8824 would be that ratio as a decimal. Lastly, tangent, that's the TOA in SOHCAHTOA. Tangent is opposite over adjacent. My opposite side is 8, my adjacent side is 15. Okay, that doesn't reduce down, and this is 0.5333. And that's it to find your ratio, okay? The trick is you just have to figure out, okay, well, what is my adjacent side? What's my opposite? What's my hypotenuse? Okay? So, look down here at the next one. Now it's asking you for the sine of B. So everything is in relationship to angle B. 8 is no longer my opposite side because if you look according to angle B, 8 is right next to angle B. 8 is my adjacent side. And then 15 would be my opposite side. 17 still stays my hypotenuse because it's across from my right angle, but basically my adjacent and my opposite sides switch for angle B. Okay, so I want you to take a minute and I want you to fill out the ratios and provide the decimal to 4 decimal places for the sine, cosine, and tangent of angle B. Pause this video to do that. Did you get these? Hope so. Okay, try this, okay? Same thing, you're finding the sine, cosine, and tangent of angle D, and then the sine, cosine, tangent of angle E. Something that can help you out is label your sides, okay? We already know that 50 is our hypotenuse because it's across from our right angle, but you have to figure out what's your opposite side, what's your adjacent side compared to the angles, okay? So try these, pause this video. Okay, hopefully you labeled for angle D, 14 was your opposite side, and 48 was your adjacent, okay? So sine, remember, SOHCAHTOA. Sine is your opposite side, which would be 14, over your hypotenuse, which is 50. Now 14 over 50 can be reduced down. They're both divisible by 2, so you should have got 7 over 25. Cosine is adjacent over hypotenuse, so 48 over 50. This reduces this reduces as well. They're both divisible by 2, so this would be 24 over 25. And the last one is tangent. Tangent is opposite over adjacent, so that's 14 over 48, and that reduces down as well to be 7 over 24, okay? Hopefully you got those. Now for angle E, you have to remember, in relationship to angle E, 48 is my opposite side, 14 is my adjacent. So the sine of angle E is going to be 48 over 50, which is 24 over 50. The cosine is adjacent over hypotenuse, so 14 over 50, which is 7 over 25. And last, the tangent is opposite, 48 over adjacent, which is 14. And that simplifies to be 24 over 7. Okay? Try the next one. You're comparing the sine, cosine, tangent for angle A for each of the triangles below. You should notice something when you do this. So pause the video and try it. Okay? So if you notice, the sine of A should have been 5 over 13, opposite over adjacent. The cosine of A should have been 12 over 13, and the tangent of A should have been 5 over 12. For this triangle, the sine of A was 2.5 over 6.5. The cosine of A was 6 over 6.5, and the tangent of A was 2.5 over 6. Did you notice anything interesting here? Well, you should have, because basically this triangle over here is half of the triangle on the left, okay? So the sine of angle A in the big triangle is the same as the sine of A in the little triangle. Because think about it, 5 divided by 13 is 0.3846. Well, 2.5 divided by 6.5 is the exact same. So you should have noticed that these triangles were similar by side similarity, which meant that their angles were congruent.